Good afternoon, my name is André, and now I'm going to present my final project in multi-agent systems. My work is 4 strategies to play a two-sided dominoes game. In this work, I created an environment to play two-sided dominoes and 4 agents, each one with a different strategy. In order to evaluate their effectiveness, a computational experiment in random blocks was performed. It was simulated 1 million matches for each pair of agents. The project was developed in C++. There are many rules to play dominoes. In this work, it was adopted the rules used in Minas Gerais to play two-sided dominoes. The 28 tiles of the game is presented in the figure. The front face of each tile is split in 2 halves. Each half has a number of dots between 0 and 6, and for each combination of dots there is only 1 tile. To play the game, the 2 players must be opposite each other on a table. All tiles must be face down and then randomized. Each player must pick up 7 tiles on stock. The other 14 must be hidden to be eaten later. Players cannot see the opponent tiles. A tile with repeated values is called double. It starts the game the player which has the greatest double, for example 6-6 or 5-5. If nobody has a double, then it starts the game the player which has a different half tile which has the greatest sum, for example 6-5 or 5-4. If there is a draw, a referee is necessary to decide which player starts the game. In its turn, the player must move a tile having 1/2 the number of the open ends. In other words, the values presented on the right or on the left on the game table. Suppose that player A starts with tile 6-6 and pass the turn. Then player B must move a tile with a 6. Suppose that player B moves a 6-4 on the right and pass the turn. Then player A must move a tile with a 6 or with a 4. Then suppose that player E moves 4-0 on the right and pass the turn. Then player B moves to 6, then player A moves 0-0 on the right, and player B moves 0-1 on the right. Observe that doubles are placed vertically and the others horizontally. The figure in this slide shows the game state of this example. Suppose a situation at which the player does not have an adequate tile to move in its turn. Then it is necessary to catch a tile from stock until an adequate one is found. For example, suppose player B moves 0-1 on the right and pass the turn. And suppose that player A does not have a tile with a 1 or a 2. Then player A must eat a tile from stock until find one with a 2 or 1. It is not allowed to eat 2 or more tiles with a 1 or 2. If the stock is empty and the player does not have the correct tile, then the turn is passed instantly. The objective of the game is to fall all tiles first. In other words, the first which plays all tiles of the hand wins the match. Another possibility to finish the match is when the game is closed, which can be happens when 2 players still have tiles and no player can make a move. For example, suppose that a 3 and a 4 are the exposed values on the table, and all 3 and 4 are already on the table. So players have tiles on their hands and they can't make a move. In this situation, it wins the player with less tiles on the hand, and a draw exists if both players have the same number of tiles. The created environment is determined by the tiles and the rules of the game. The environment can be classified as accessible but with incomplete information, as it is not possible to observe the tiles on the opponent's hand and to forecast the opponent's moves. The environment is also dynamic, because the environment changes at each move. And finally, the environment is classified as discrete, once all tiles and moves are discrete. The agent type of this project is an agent which plays dominoes. As a performance measure, was used the number of moved tiles. As actuators, the agent can move a suitable tile, catch a tile on stock if necessary, and pass the turn. As sensors, the agents can observe tiles on the table and observe tiles on its hand. As mentioned before, I created 4 agents with different strategies. Their names honors the brave Dominoes players that drink cachaça and eat crackering in a game session which spends all night. Their names are Juca, Pinduca, Tiao, and Nabucodonosor. Juca is an agent which only observes the values at which tiles must have on one half. In other words, the values on the left and on the right side of the game on the table. Juca selects at random the first tile in a suitable configuration. In other words, if it's placed on the left of the table or on the right of the table, or if it is necessary to spin or not spin the tile. Juca simulates a novice player which only knows the rules of the game. Pinduca is an agent which first selects a subset C of all tiles in an adequate configuration, and then computes a simple probability for each tile configuration I. The probability takes the number of contrary side value of the configuration I, which Pinduca can see on the table and on its hand. For example, in this picture, Pinduca computed the probability for V5, because V5 is the number of the contrary side value in this configuration. So, Pinduca sorts all candidates by PI and selects and moves the tile in a configuration with highest PI. The contrary value of these tiles on Pinduca's hand is such that the opponent may not have with highest probability. Tiao is another agent which uses a probability function in order to decide a tile to play. But in this case, Tiao used the 2 possible future end values on the table. Tiao selects a subset C of all appropriate candidates and then computes the probability for each configuration I. Pi is computed as Vi times Ti divided by the sum of all V key times T key in the set C. In the figure, the example shows a red tile which will be moved. V5 is the number of 5 which Tiao can see, and T1 is the number of 1s which Tiao can see. Tiao sorts each candidate by Pi and then selects and moves the tile in a configuration with the highest Pi. So, Tiao moves the tile which will embarrass the opponent player in a general way, because Tiao analyzes the 2 future values of the game on the table. Nabucodonosor as Tiao does, also use the two possible future end values on the table. Nabucodonosor selects a subset C of all appropriate candidates and compute a probability for each configuration tile I using the Boltzmann exploration technique. Pi is equal to the exponential of Vi times Ti divided by U divided by the sum of exponential of V key times T key divided by U for each key in C. V and T are as explained before, and U is the temperature function. After the computation of the probability values, a roulette wheel selection is performed in order to select a tile. The tile which will embarrass the opponent player in a general way is chosen in this strategy with a random effect. As mentioned before, a computational experiment was planned in order to analyze the efficacy of each agent. It was simulated 1 million matches between each pair of agents in a random block experiment. The number of victories, losses, and draws were stored. This slide shows the proportion of wins and draws for each pair of agents which was simulated in 1 million matches. The pie graphics represent, respectively, the matches between Juca and Pinduca, Juca and Tiao, Juca and Nabucodonosor, Pinduca and Tiao, Pinduca and Nabucodonosor, and Tiao and Nabucodonosor. In a proportional way of view, Juca, the random player, was the worst agent. Pinduca, the agent that computes a probability based on the contrary value of the tile which will be moved, only won more matches against Juca. Tiao, the agent which computes a probability value based on the contrary value of the tile which will be moved and based on the future other side of the exposed value or open value on the table, was better than Juca and Pinduca. Nabucodonosor, the agent which analyzes the future exposed values of the game on the table and use Boltzmann exploration to compute the probability value, was the best agent to play two-sided dominoes in a proportional way of view. This bar graphic shows the total number of wins of each agent. We can see in this graphic the superiority of Nabucodonosor, followed by Tiao and Pinduca, as mentioned in the earlier slide. To conclude this work, we can see that Juca, the agent with random strategy, was the worst player. Juca has the smaller win proportion in our experiment. However, it obtained victory rates between 0.32 and 0.35, what it means that random strategy can obtain a reasonable amount of wins in this incomplete information game against other more sophisticated strategies. Pinduca, the greedy agent which only analyzed its tile end, was the winner against Juca, but it did not obtain the same success against Tiao and Nabucodonosor. This means that it is better to observe and analyze the state in a global way in order to decide which the promised tile to be moved is. Tiao, the agent which has the strategy of analyzing the next two ends of the game on the table, won the agents Juca and Pinduca in a rate point of view, But this situation did not repeat with Nabucodonosor. The fact of choosing the tile with highest probability of embarrassing the opponent on the next two end showed to be efficacy against novice strategies. Nabucodonosor was the fucking agent. It won in percentage all others' agent strategies. This was possible in addition to the general analysis of tiles on the table and on its hand to embarrass the opponent's strategy, because of the random selection of the tile configurations with different probabilities due to their computed importance at observing the end values. As future work, I pretend to create and analyze new strategies like prioritize the discard of the player tiles according to the values which are more common on the hand, and I want to alternate strategies during the match. For example, I want to discard the more common values, and then I want to embarrass something like that. And I want to ask Professor Fred whether can we publish this work in somewhere. And to finish my presentation, this is the bibliography that I used